So, as always, we will start with our land acknowledgement. We would like to acknowledge that the lands on which we gather is the traditional territory of the Haudenosaunee and Anishinaabe nations. The territory was the subject of the Dish with One Spoon Wampum Belt Covenant, an agreement between the Iroquois Confederacy and the Ojibwe and allied nations to peaceably share and care for the resources around the Great Lakes. We must recognize, like the peoples of the Haudenosaunee and Anishinaabe nations, that the dish represents a common area of land, and the one spoon means that we all have to share this land equally. We are grateful for the opportunity to meet here, and we thank all the generations of Indigenous peoples who have taken care of this land and recognize and deeply appreciate their historic and contemporary connection to this place. While this acknowledgement is a good start, we encourage all of you to learn more about the Wampum Belt Agreement, and you can do that by checking out this link at the bottom, native-land.ca. So our speaker today is Julie Bolduc-Duval. She's an astronomer and science communicator who has been sharing her passion with the public for over 20 years. She is now the director of a program called Discover the Universe, an astronomy education program supported by astrophysicists across Canada. She loves helping teachers across the country and around the world share the wonders of the universe with their students. In 2020, her work was recognized by the Keelak Award for Science Communication from the Canadian Astronomical Society. So with that, I welcome and I thank Julie for joining us and ask her to take us on this tour of a fascinating universe.
Thank you very much, Sandeep, for the introduction, and thank you for inviting me. I'm very happy to be here with all of you. I'm actually joining you from not from the Hamilton area. I'm in my home in Quebec, in a city called Thetford Mines, which is actually on the territory of the Wendat and Abenaki nations. So actually, when I did my own land acknowledgements, when I had to look for, whose land am I on, I had to go to the same website that Sandeep just mentioned and learn about the history of this place. And it was very interesting to do that. So I invite you all to do it as well. So as I get started, I want to tell you a bit about myself. So you already know I have many animals. Actually, I realized the numbers were even wrong in between what I sent, I don't know how many weeks ago, and now we have a new puppy. So we have now 3 dogs, but one of them is almost 14 years old. So we don't think he's going to last much longer. But yes, so you already know a bit about me, but if I was to go back many years ago, maybe when I was 8 or 9 or around that age anyway, you probably wouldn't have thought I would have become an astronomer. I was fascinated with whales. I used to go whale watching all the time, well, at least once a year with my dad. And so that's actually further east a bit here in Quebec. And I'm standing in front of a big skull of a whale. So there's a whale on my shirt. So anyway, I loved whales. So you probably thought I would have become a biologist or something like that. And it's interesting because, I was probably a little scientist. Actually, I used to be curious about nature all the time and ask questions and wanting to know more about the universe in general, like just nature and the universe. And when I was 18, I got a chance, just before university, actually, I got a chance to work at an observatory in Quebec, in Mont-Mégantic, which is a fantastic place. It's a national park. It's a beautiful place. There's an observatory there. And I got to work in the astronomy museum. So that's where I learned a lot about astronomy. Actually, my interest for astronomy started mostly when I was around 13 or so. And I felt very lucky I got to have a job at 18 in an observatory. I see there's a hand up. Gabby, do you have something to ask me already?
Did you tell any natural experts about your finds?
My finds in terms of?
Yeah, like the big bones that you found.
Oh, well, I didn't find it. I mean, I would have been amazed to find that thing. It was there on the truck. As you can see, it's like on the trailer. But no, I didn't find it myself. But we went whale watching and that was on display. I guess it was a stall.
Oh, okay.
But no, yeah, definitely I would have told someone if I had found that on the beach. Can you imagine that? That would be fascinating. Yeah. But yeah, no, it's pretty big, right? That's just a skull. Okay, so yeah, I got to work at an observatory in Quebec. Then I moved to British Columbia and worked in Victoria. I went to the university there actually, and I worked at an observatory there. And this is the big telescope inside the observatory. So this is the telescope inside the dome here. And a big telescope like this, just to let you know, because I'm going to come back to telescopes a bit later. That's actually mostly an empty tube. It's mostly empty here. And at the bottom, there's a big mirror. And this mirror here was 1.6 meters across. So it's about the height of an adult, but it's a big circle. And that's the size of the mirror is basically how powerful the telescope is. So the one in, this one is 1.8 meters across. So a tall adult. The one in Montmégantic was 1.6 meters across. But the biggest telescopes in the world today are 10 meters across the mirror. So that's huge. But I got to control that telescope quite a few times. Actually, in the picture above, I'm the one controlling the telescope on that picture. And we're projecting the images from the telescope directly on the wall. So there's no eyepiece to put the eye on anymore on those research telescopes. You take pictures with a digital camera, and then we're projecting them on the wall. So that's why you see light inside the dome. Usually it would be completely dark, but the light comes from the fact that we're projecting a picture. And one thing I was really pleased of doing was about 20 years ago, I got to go to Hawaii on Mauna Kea, which is one of the big mountains there. And it's one of the best places in the world to do astronomy. So there are many telescopes, and I got to spend 2 nights on one of the top science telescopes in the world called the Canada-France-Hawaii telescope. And actually, I'm standing on the catwalk around the observatory, but the telescope behind me is the Gemini telescope, which is an 8-meter telescope. So the building is pretty big because inside there's a telescope with a mirror 8 meters across. So it's very, very big. Like 8 meters, that's the size of a classroom, or even a bit less, but around that size. Just imagine that's just a mirror, and then imagine the structure around it. So that's what I did sort of and I've been working in astronomy education for many years, and now I run a program called Discover the Universe. So there's some content for kids directly on there, but not a lot. It's mostly for parents or educators or teachers to go and find ideas. I'll share a few links at the end, because there is one page. If you go to our Astro at Home page, that's when we had a lot of talks for kids directly. That we did that during the first wave of the pandemic. We have 50 lectures on different subjects. Oh, I see a question in the chat. How many pets do I have again? I have 4 cats, although one of them is 17 years old and he's probably going to die in the next few weeks. So that's kind of sad, but that's part of life. So 4 cats, we have 3 dogs. We have, I think we're up to 13 chickens and hens right now. My son has a gecko and my husband has a tarantula. I don't take care of the tarantula myself. I don't mind having one in the house, but I don't take care of it. Okay, so I've been doing astronomy for 20 years, and there are many things I find fascinating. So I decided to do my top 5 in this talk. So I'm going to talk to you about the top 5 fascinating things that I've loved about the universe. And let's start with number 5. Number 5 are solar eclipses. Now, you might know about solar eclipses because that's part of the curriculum. You might have learned them in school, but they're actually amazing phenomena to observe. And I have a question for you right now. Well, actually, I'm just going to put this image first. This is a picture taken last June. So June 10th, 2021, we had a partial solar eclipse visible in Canada. And in some parts, actually, of Canada further north, it was what we call an annular eclipse. So all they could see left was a ring of sun with the moon covering it. So what you see now here is the moon. There, the moon is covering the sun, and you see a crescent sun. And this is a beautiful picture taken by a friend of mine, Remy. And this is actually the Montmégantic Observatory right there. Now, my question for you is, have you ever seen a solar eclipse? That's the kind of eclipse you need to wear eclipse glasses for. So if you remember putting those on, if you've seen one, you can put it in the chat, or maybe put a thumb up. A few of you, at least one person has seen one. Oh, someone got to see one in 2017. So that might have been even a total solar eclipse, which is even better. I must admit, I was also in the United States in 2017. I'll talk to you about that one in a second. It's very beautiful. And I'm talking to you about solar eclipses because there's a chance there'll be a major one above where you guys live in 2 years. So I'm going to tell you about that in a second. So some no's in there, disappointment. You'll get to see one soon, I hope. Okay, so just quickly, what is a solar eclipse? Well, that happens when, the Earth goes around the sun, but the moon goes around the Earth, and sometimes it lines up with the sun perfectly, and then the shadow of the moon falls on the Earth. So that's what you see here. This is not to scale, but it's just showing you, you have the sun very far away in that direction there. Then you have the moon, and then it casts a shadow, and the shadow sometimes falls on the Earth. If you're in that small area here, you get to see a total eclipse where the moon covers the sun completely, and that it gets dark, and it's actually fascinating. But if you live in the other area here, you get to see a partial eclipse, the way I just showed you, where you still see part of the sun, but it's covered by the moon. Now, the drawing I just showed you is not to scale. This is to scale. So you can see how the moon is very small compared to the Earth, and it's quite far away. We tend to think they're much closer, but actually quite far away. So most of the time, actually, the alignment is not right. And that's why we don't have eclipses every month when the moon passes between us and the sun, because most of the time its shadow will fall either above or below the Earth. But once in a while, actually every 6 months, the alignment is right and there's a solar eclipse, but you're not always lucky enough to be right underneath it. Sometimes there's a solar eclipse visible only in Antarctica or in other parts of the world, and not where we live, so we don't hear so much about it. Here's what a solar eclipse looks like from space. So this was the 2017 total solar eclipse. North America is here, and you can see the shadow of the moon going across here. These are real pictures taken by satellites. They took pictures of the Earth during that day, and you can see the Earth rotates, and you can see the shadow crossing. And I was about there at the time of the eclipse, and I got to see Totality when it's a total solar eclipse, and it was pretty neat. So someone else got to see that. I saw that in the chat. And what happened, so these are pictures from that eclipse. These are not pictures that I took myself, but it was someone next to me. He was actually from Barcelona, and we happened to be there together observing the eclipse, because people travel all around the world to see the eclipse. This is a picture taken with a solar filter. So when you look at a solar eclipse, you always have to be careful. You're looking at the sun, and that's very dangerous for your eyes. So that's why eclipse glasses exist. And you put them in. Right now, I don't see anything through my eclipse glasses because it's too opaque, but it only lets the sunlight through just enough for us to see it, but without hurting our eyes. So it's very important when you look at a solar eclipse to put eclipse glasses on, and not regular sunglasses. You need eclipse glasses, special ones. So this is the beginning of the eclipse, when the moon is here and it's starting to cover the sun. And it takes a few hours for the moon to move in front of the sun, and eventually you get totality. So this is a total part of the eclipse. It doesn't last for long. For me, when I was in the States in that location, it only lasted 57 seconds. It can be up to 5 or 6 minutes, depending on the alignment sometimes, but it doesn't last long, and it's an incredible view. What you see here is actually what we call the solar corona. It's the outside atmosphere of the sun, in a sense. So usually we don't see that because it's not bright enough. But when the sun is completely covered, then suddenly we get to see the corona around it, and it makes for a beautiful sight. This image was actually taken without solar eclipse glasses, because when the sun is completely covered, you can take off your glasses for those 57 seconds to see this in the sky.
Do you want to go ahead and ask your question?
Yeah, actually, have you guys ever seen a lunar eclipse?
Yes, I've seen lunar eclipses, and actually lunar eclipses are more common because on average you can see a lunar eclipse about once a year, depending on where you are on Earth. For a solar eclipse where you're located, it's more rare because the area where you can see the eclipse is not as big. And there's going to be one this May visible across Canada. Actually, this year we have 2 lunar eclipses visible across Canada, so hopefully you get to see one. I'm wondering, and sorry I missed your name, but have you ever seen one?
No, but I heard that last year a lunar eclipse happened on November.
Yes, that's true. There was one in November, and
but I was on vacation that time, so I couldn't see it.
Oh, well, I know for me it was completely cloudy, so I didn't get to see it. It happens, right? That's something about astronomy, is that you can't see through the clouds, so sometimes it's a bit tricky. You don't get to see exactly what you want to see in the sky. I see there's another question. Do you want to take it now?
My French teacher was able to see that eclipse.
Awesome.
It's the same eclipse I remember.
in November. There'll be another one this May. So again, lunar eclipses is not as rare. They're great. They're beautiful to look at. They're not in my top 5 though. They're beautiful, but solar eclipses are a little bit more impressive. Okay, I'll take another question and then I'll continue with my presentation. So go ahead.
And that eclipse kind of looks like a black hole.
You're right. You're right. Actually, the picture I have on right now is just after totality. So when the moon moves a little bit more, I mean, it always moves in its orbit, right? But at some point, it gets a bit further away from the disk of the sun, and then you can see the sun reappear a little bit. And that's sort of, that's when you need to put your eclipse glasses back on, because then there's enough light to actually hurt your eyes. Even though it's not a lot, there's enough. But yeah, you're right. It looks a bit like a black hole in the sky. I'll show you a picture in a minute that's even more impressive. And then after that, then, the moon keeps going, and then that's the end of the eclipse. Again, the moon is right here. It looks like it's just a part of the sun missing, but you have to imagine that the moon is here in front of the sun. And this is the part I want to show you with sound. So this was taken in 2017. It's just a short clip, 1 minute, but it shows you the reaction of the crowd as totality arrives. So as the moon finally covers the sun completely, you notice this change in luminosity just in the final few seconds, and pay attention to the little boy in the front. I think you'll find it interesting. Can you all hear it? So does that make you want to see a total solar eclipse? This is how excited people get in the last few seconds when the sun disappears, and then a minute 50 later you get to see like the excitement again as the sun reappears. You get to see the luminosity that was different. But just that reaction, this is what I felt personally when I got to see my first total solar eclipse in 2017. It's just mind-blowing, that the feeling that you see, the feeling that you get. And you have to wait 2 years, but there is a total solar eclipse that will happen over Hamilton on April 8th, 2024. I'm wondering, is anyone's birthday April 8th here? Oh yeah, perfect. That's just as I was asking. So someone, Wolf family, on April 8th, 2024, you'll get a total solar eclipse for your birthday. So this is from a website that, again, we'll share in the chat. But this is, and it's weird because my computer's in French, so it kind of picked up half French, half English here, 8 Avril 2024. Anyway, but what I'm going to show you, this is a website you can go to find where you're located, exactly the timing of it. But what I just want to explain quickly. So what you have there is everywhere that's shaded is where people will see an eclipse. In the red band, the very darkest red band is where you'll see the total solar eclipse. So as you can see, it's a pretty thin band, and you have to be lucky to be right where it is. And let's zoom in a little bit. I just created this animation quickly myself. There you go. Look at that. Hamilton is right in it. Toronto just misses it, but Hamilton will get totality. My house, actually where I'm located in Quebec, also gets totality. Someone's excited there. And it will be in the middle of the afternoon, so around 3:19. It's on a Monday afternoon. I know it's 2 years away, but actually, us astronomers are already working about this eclipse and trying to make it a fun experience for everyone, and make sure everyone has eclipse glasses to be able to observe the full show safely. So you'll hear about it again. But yes, total solar eclipse over Hamilton in 2 years from now. This is actually the only time in your lifetime there will be a total solar eclipse over Hamilton. So it's pretty exciting. It's a once-in-a-lifetime opportunity, and we hope it's going to be clear and no clouds, because that would be disappointing. It will still get dark, but yeah, I mean, if it's going to happen once in your lifetime, you want it to be clear skies, right? And I just want to show you, so the question earlier, that, you know, it looked like a black hole in the sky. Again, this is a picture from my friend Remy, who's an amazing photographer. And this is the view that you get when you look up when it's totality. You look up, you see this corona around the sun, but then it looks like there's a black hole in the middle, right? And it's just a surreal feeling to see that. It looks different. It's darker. It's not completely dark. It's not like it's nighttime, but it's much darker. You can see some stars, and you look up and you see that. And it's just amazing. And you can imagine how a long time ago, when people didn't know what eclipses were, no wonder it was scary, because the sun disappears and there's a black hole instead, right? Obviously, it's just the moon covering the sun, but still, it's nothing dangerous. You just have to be careful not to look at the sun directly. But it's not, I just want to highlight that, mention that it's not more dangerous during an eclipse than during any regular sunny day. It's just that on that day, you want to look at the sun. So that's why you need eclipse glasses. These work any day, actually. I could go outside today, it's sunny, and look at the sun through this, and I would see the disk of the sun. But during an eclipse, it's fun to see how it shrinks, in a sense, and eventually it disappears. So that's why solar eclipses are my top 5, because it's a really amazing experience. And I don't feel so bad talking to you about how amazing it is, because it's coming your way. In 2 years, you'll get to see one. Now, number 4 is the beauty of the night sky. I love looking up at the night sky. And people sometimes ask me, you know, how many telescopes do you have? And actually, I have a very small telescope that I mostly use for demonstrations when I go to classrooms, or for training teachers, telling them how it works. Because when I go outside, I prefer to look at the night sky with my naked eyes. It's just, you know, a beautiful sight. Of course, I live away from city pollution, light pollution from a city. So the sky is much darker. Of course, if you live in a city, unfortunately, the city lights affect the view and you don't see the sky as well. What I'm going to show you here is from the Canada-France-Hawaii telescope. So the telescope I was at many years ago. And this is a time lapse from their night camera. So it's looking east. You can see the city of Hilo here underneath the clouds. So again, light pollution from a city. The clouds are below them because they're so high on the mountain. And it goes faster, but you can see the stars rise. These are the Pleiades, a small cluster of stars. And you can see how everything moves up. You know, and it's beautiful to see everything in the sky like this. Here's something bright. You might think it's the sun, but it's not the sun, it's the moon. You can still see the stars at the same time, right? So it's the moon. We can see the clouds are lit now by the moon, and you can see the stars. It's a beautiful night sky. There's not much light pollution there. That's why they put the observatory there. And every night, actually, they create a time lapse like that. So it's pretty nice. And now it's sunrise. So we're going to end here. And, you know, just coming back here for a sec, I say the stars are rising. We're looking east and the stars are rising, or it's the moon rise, or the sun rises in the east. But it's actually not those objects that are moving. It's us. It's the Earth that's spinning in the opposite direction. And my next video is going to show just that.
Julie, before you start that video, could you stop? There's a couple of questions. I wonder if you want to take those now.
Oh, I could. Sorry, I couldn't see them. Yes.
Yeah, no, that's okay. Do you want to start off? Do you have a question?
For the previous video, I saw something near the moon. Like it looks kind of purple, like an oval.
Yeah, let's have a look. Oh, this is just a reflection. The moon is so bright, it creates a reflection in the camera. So it's not something that really is in the sky.
Okay.
That's good.
Thank you.
Do you have a question?
You know, when there's like no light pollution, like when you went back to that second video, that's reflection of Milky Way.
Yeah. So yes, before I won't make the video move yet, but yeah, this is the Milky Way. So it's our galaxy. Actually, it's basically a region where we look up in the sky that has so many stars in it that it creates this wide band across the sky. And it's really the disk of our galaxy. And you can see a lot of darker regions as well. Those are clouds of gas and dust. So there's dust everywhere in space. So maybe I shouldn't say that because I'm a mom myself, but next time, you know, your bedroom is dusty, you can say, well, Mom, there's dust everywhere in the universe. The astronomer told us. But, you know, it's still not a reason not to clean it. But yeah, that's really, those are clouds of dust here. But yeah, beautiful Milky Way.
And then, sorry, I can't see your full name.
Yeah, in the other video, why did the moon look like the sun?
It's just because it was so bright. It was kind of, it appears, sometimes when an object is really bright on very sensitive cameras, it appears bigger than it should be. So it appeared bigger. It was probably not even full moon, but it looked full and just kind of like the sun, just because it was, the camera was so sensitive.
No, I meant like, why was the moon glowing?
Oh, well, the moon is, okay, hold on, I'm come back here. The moon is, yeah, so it looks like it's glowing, right? It's very bright just because the camera is so sensitive, because the moon does not shine on its own. It reflects light from the sun. So usually it does not appear this bright, but the camera is so sensitive to see all those stars in the background that the moon ends up being brighter on it. So it's just maybe a matter of how the camera works. It would not have looked like that with the naked eye. I guess that's another way to say it.
Last question for this time.
When is the exact time that there will be a lunar eclipse?
Actually, you know what? Maybe at the end, on the website we shared for the eclipse on April 2024, at the bottom, you can look for it. You can ask for it to show you like the next eclipses worldwide, and it will tell you the lunar eclipses as well as the solar eclipses.
Thank you.
And then you could click on Hamilton and get the exact timing for where you live. Does that work?
Yeah, thank you.
Perfect. I think actually the one in May, if I remember right, is going to be right in the middle of the night for us, and it's on a Sunday night, so it's not ideal. People on the West Coast, it will be easier for them to observe it in the evening. But yeah, sometimes you have to, if your parents are really keen, they could wake you up in the middle of the night to go see the eclipse. Okay, so let's continue. Yep, perfect. So I'm going to play this video. So again, remember the video earlier where it looked like everything was rising on the horizon? This is actually what it should look like. Notice something weird here? Right? It looks like the horizon is moving and the sky is staying fixed. And this is, this is a video they took with the camera, and they kept the stars fixed on the camera, and they moved, and it looks like the horizon is moving instead. And this is actually what's happening in space. It's not the sky that's moving, it's us that's spinning. And as we're spinning, like the Earth, makes a full circle in 24 hours, we don't feel like we're moving, but it makes everything in the sky appear to move. So that's why the sun rises in the east and sets in the west. All stars do the same thing. And this is kind of making you feel almost like you're going to fall here, but you don't fall. It's just, the Earth moves around. But again, it's a beautiful sight. And the sky always changes night after night or hour after hour, because things rise and move across the sky. So it's interesting to see how the cycles change from night to night as well. Sometimes you get to see planets, and of course the moon is visible in the city. So I know the sky from a city is not as impressive as from a rural area, but this is a view last fall. You have Venus right here next to a crescent moon. And this is a sight you can see from anywhere. Like in a city, you can see that as well. And it's really beautiful to observe it. And if you just, I tend to tell people, like, just look up, right? Sometimes 5 minutes when I come out of the grocery store, as I'm putting the bags in the car, I'm kind of a nerd for that. I'll always look up and say, oh, is it clear outside? Is there anything I can see? And if I know it's when there's a planet visible, I'll look for it right away. Right now, there's no planets visible in the evening. We had Jupiter and Saturn up until New Year's, roughly. But if you wake up early in the morning before it gets really bright, look east and you might see Venus. And Venus is extremely bright. People tend to think, sometimes it's a UFO in the sky because it's so bright. So if some of you have seen Venus early in the morning in the last few weeks, you can write it down in the chat. Actually, that will be interesting if some of you have noticed that. It's in the east. So again, you have to think of where the sun would rise and look in that direction before it gets too bright.
Venus many times, and I've showed you many times, and I'll find it tonight.
Oh, so I heard a voice saying that they've seen Venus. That's awesome. So yes, planets are visible even in the city, the moon as well. And sometimes when you're away from all lights, you get amazing shows. And this is taken by another astronomer I know, Alan Dyer, in Alberta. I'll put the music. And he got to see Northern Lights last year on Thanksgiving Day. And look at, this is a weird image. In a sense that it's an all sky camera. So you're looking at the horizon and it looks like the horizon is curved just because it's looking at the all sky. And look at that, those green lights dancing in the sky. Those are Northern Lights. or aurora borealis, as someone put in the chat. It wouldn't look exactly like that from a city because of light pollution again, but sometimes you get amazing shows like that. And look at the Milky Way as well, the band here. And you can see different colors. It's mostly green, but there's some red as well. It's so beautiful. 2 years ago, just before that pandemic, actually, I got lucky. I got to go travel to Iqaluit in Nunavut, and I got to see the best northern lights I had ever seen. It was so bright in the sky. It was minus 40 degrees outside, but I stayed there for half an hour just in awe of the beauty of the night sky. So again, I know from a city it's not the same, but I invite you to look up as often as you can, because you might notice things. And even if you see like just the moon, right? You've seen the moon before, but then try to observe it night after night when you see it, how it changes. And have you ever seen the moon in the daytime? Have you ever noticed that you can see the moon in the daytime? If you have, again, write it in the chat. For some people, it's obvious, but some people have never paid attention to the sky in the daytime and seen the moon. So yeah, perfect. Many people have seen the moon in the daytime. So make sure you look up. I love saying that. Just for 5 minutes, right? Look up and observe the sky. So before I get to 3, are there any questions about the night sky and what you can observe?
I'm just wondering, what telescope would it take to see a black hole?
Oh, that's a very good question. Actually, if you had asked me that question a few years ago, I would have said it's impossible to see a black hole because it does not emit any light. It's black, and you can't see it. However, there's stuff happening around the black hole that's kind of weird. And a few years ago, they got to take the first image of a black hole. And what you see is not necessarily a black hole itself, is the matter around it. And that was taken by a series of radio telescopes. And it's a complicated process. I don't fully understand it myself, but they had to link together many telescopes around the world to take that picture. And it's not something you could take, in your backyard with a small telescope, definitely. It's more complicated than that because black holes are very tricky. And someone mentioned James Webb. I'll come back to James Webb in just a minute. Maybe we'll take the 2 questions that are here and then move on. Is that okay?
Oh.
Hello.
Yeah,
Hello?
Go ahead.
What's inside of a black hole, and is it infinite in there?
It's not infinite. It's actually infinite pressure in a sense. So a black hole is something, I didn't even put that in my top 5. Actually, black holes are kind of neat. They're very strange objects in a sense that we don't fully understand how they work. So basically, you take a lot of matter. Let's say you take the Earth, the full planet, and you squeeze it extremely, extremely small. It would get extreme pressure, right? More mass into a small volume, and you get extreme density, if you've learned that concept. So very, very dense, a lot of pressure. And at some point, it gets so weird. The gravity around it gets so weird because of the pressure is too high inside, the density is too high. But what's inside of it, I think, is just matter that's really, really, really squished. So I wouldn't want to try it and see what's in there because I would get squished too. And it's, we don't think it's like, in science fiction, you see like it's a gateway to something else, like in Interstellar, the movie, if you've seen that, and so on. But I think it would just get you crushed if you went in there. So no, it's not infinite. So that's the answer in 1 minute about what is a black hole. But something I want to add is that it's not a giant vacuum cleaner. Sometimes we hear like it's going to suck everything, right? It's not sucking everything. If you're far away from the black hole, there's no problem. Just if you get very close to it. For example, if the sun was to turn into a black hole like that, it won't. Don't worry. But if it were, the orbit of the Earth would stay the same. The Earth would keep going around the black hole without any problem. We wouldn't get sucked into it. So you don't have to be afraid of black holes flying by and getting sucked into them. They're so far away, there's no problem. But there are some. And someone mentioned, or Sophia, I think it was, but anyway, that there's a giant black hole in the middle of the Milky Way in the center. But there are many other black holes in the Milky Way as well in our galaxy.
Do you have a question?
Oh, yeah. I want to ask how black holes were created.
So there are different types of black holes. And I'm just going to talk about one type because I could go on and on about black holes. But one type is created when stars end their lives. Some stars are much more massive than the sun, and at the end of their lives, they'll sort of collapse onto themselves and get squished and squished and squished. And that's how a black hole can be created. Those are not the giant black holes we find in the middle of galaxies, what we call supermassive black holes, but they're what we call stellar black holes. So stellar means star. So they're black holes formed by a star. And we know those exist, and it happens when stars die, sort of run out of fuel, and they get squished. Again, the answer in 1 minute.
Yeah, that's right. These are very complicated answers.
Would it be possible to use a telescope to see inside a black hole?
No, we can't, because the inside of the black hole is, again, the gravity is so strong that not even light can escape it. And the way we can see things in the universe is because of the light of the objects. So there's no way we could see inside the black hole. Like, for example, let's imagine you could stand on a black hole. You couldn't, but let's figure out a way that you could stand on a black hole and you had a flashlight pointing up. The light would curve and come back down. It would never escape the black hole, right? So that's kind of weird to think about. Gravity is so strong that not even light can escape. But that's something that blows our mind to imagine, because that's completely out of our everyday experience. Lots of questions on black holes, right? But
So,
I need to keep going. Sorry, did you take the last question?
Let's move along, Julie,
Okay.
Julie, and then we'll come back to more questions.
Okay. So I want to show you some beautiful pictures of the universe, because that's something I love about the universe. It's really pretty, and we have amazing pictures of it. So let's have a look. The first one here is a video. Okay. All right, there's a bit of music on that one. I'm just going to lower the volume a little bit so you can hear me. So this is Jupiter as you've never seen it. It was taken by a space probe, the Juno probe, that's currently in orbit around Jupiter. And sometimes it dies very close to Jupiter. So those are the clouds of Jupiter, and the swirls and the colors, and it looks like a painting, right? It's so beautiful. And Juno has been taking amazing pictures and videos of Jupiter like that during a close flyby like this. Look at all those swirls. Like those are clouds on Jupiter. So those are all storms, basically. And look at all those weird shapes and vortex. And those are probably hurricanes. They're the big ones, big circles. So sometimes we complain about the weather on Earth. Really, it's nothing compared to other planets. Other planets are much worse. There are some storms on Jupiter that have been going for hundreds of years, and some of these circles, they're actually the size of the Earth, just so you know. Like it's huge. I see a question. This type of video, this one is the Juno mission, and actually I'm gonna write something in the chat very quickly. Do a search for Juno Peri-Jove. Peri-Jove means when it gets close to, Peri is close to Jove, Jupiter. So every time it flies close to Jupiter, usually they create a video. So if you look on YouTube for Juno Peri-Jove, you should get a bunch of videos like this one. They're really beautiful. So that's one of the beautiful things about the universe. This one might not seem that impressive. It's a black and white image, okay, like it's not super high quality and so on. What I love about this is a picture of Pluto. You know, when you think of Pluto, the dwarf planet very far away in the solar system, and you think it might not look like much. And in 2015, when the New Horizons mission flew by Pluto, it was the first time we saw Pluto up close. And I think everyone's mind was blown away by the pictures that we got. These are fields of ice and actually mountains of ice on Pluto. But it looks like very Earth-like in a sense, right? Like, you know, that's the kind of landscape you could get on Earth. So, but you can get a sense that it's smaller too. It's much smaller than the Earth, because you can see the curvature. Look at the size of the mountains compared to the curvature of the planet, the dwarf planet itself. I just love that picture of Pluto. And yes, it looks a bit like the moon, but this is really, really far in the solar system, and we can still get pictures like that. But if we leave the solar system, you know, and we look at through telescopes, not probes anymore, but really telescopes looking up in space, then we can see amazing things in the sky, and it's really beautiful. Like here, the star field with stars of different colors. Stars do have different colors, and you can see that here. And the color indicates the temperature. The hottest ones are blue. And the less hot one, I don't say the coolest ones because they're still very hot. They're still thousands of degrees. The less hot ones are red, and you can see that here. And stars are formed in beautiful nebulae. You can see that here. Like this is a huge cloud of gas and dust where new stars are formed.
Is that Orion Nebulae or is it Eagle Nebulae?
This is actually neither. It's not the Orion Nebula nor the Eagle Nebula. I don't remember the name of this one. I don't think it has a common name like Orion or Eagle. I think it's just like maybe a number, but I find it very beautiful. So I put it in my presentation.
Because it looks familiar to those both.
Yeah, you're right. It does look similar a little bit. I don't think I have pictures of those. I have the Horsehead Nebula, so I'll show it to you. There it is. This one is called the Horsehead Nebula because, you know, it looks like a horse head right here. This is, and behind you can see a cloud of gas, mostly hydrogen, and hydrogen glows pink red. So it looks very beautiful like this. But if you look at the horse head right here and you take another telescope that can see a bit better, this is actually taken through a different type of light as well. This is an infrared image, so you can see the gas better. And yeah, so that's the horse head right there. I find this image just, you know, mind-blowing. It's really beautiful. This is huge too in space. Like it's just incredibly big, and it's very far away in space. And look at that. That's a dying star. And yeah, the star ejected its outer layers. Won't blow up. It won't turn, this type of star won't blow up and turn into a black hole that I mentioned earlier. Yes, this is a Cat's Eye Nebula, is the question. And this one was taken by the Hubble Space Telescope, but also the Chandra Telescope. It's another one. They processed it together. I will talk about the Hubble Space Telescope in a second. But yeah, many of the pictures I'm showing you are taken by Hubble. But that one, if I remember right, was taken by the Canada-France-Hawaii Telescope, the one I showed you earlier, where I was actually 20 years ago. So again, another dying star, you know, beautiful shapes and colors. The colors sometimes are not completely real colors. But it's, you know, they kind of put different colors to highlight different details, but still, you know, the shape is just amazing. And then we can look further away and we can see galaxies. So everything I've shown you so far is part of our own galaxy. And now we're looking at other galaxies very far away. This is the Andromeda Galaxy, our neighbor, and galaxies are really pretty as well with their spiral arms. And sometimes galaxies interact, and this one looks almost like a big galactic rose. You know, it's almost like a rose you could hand out to someone, but it's just, except that it's way too big and really, really, really far away. So yes, this picture, for example, was taken by the Hubble Space Telescope. And the Hubble Space Telescope, why it's so popular, it's because it's above the Earth's atmosphere. So it's this one. It's smaller a little bit than the other one, and that's the Hubble Space Telescope. It's been in space for 30 years. The reason why it's so great, because it's in space, not because it's closer to the objects, because it doesn't make much difference. That 400 kilometers compared to light years does make a difference. But because it's above the atmosphere, it gets a much sharper view of the universe, and it can take very sharp pictures. You can see below the telescope is the size of the mirror. It's 2.4 meters across, and you can see a person next to it, actually. So it's, you know, it's bigger than a person. But the telescope on the right is the new one we just launched. The James Webb Space Telescope got launched on Christmas Day, December 25, 2021. And you can see its mirror, golden mirror, is actually much bigger. It's 6.5 meters across. You can see next to a person again at the bottom. And we haven't received really good images of James Webb yet because they're doing some tests and everything, but you will see pictures of James Webb in the next few years, because it's going to be fantastic what it can give us, the view it can give us of the sky. And yes, it is the most expensive scientific project ever. It cost, James Webb, I think, is more like $10 billion. So it's a lot of money, but I've been hearing about James Webb for 20 years, right? So it's a huge project. And finally, it's up in space. Scientists are very happy with that. I'm going to move to the size of the universe. I've been showing you beautiful pictures and telling you how beautiful the universe is, but it's so incredibly big. It's really hard to wrap your head around that. So let's start with something close to us. Let's say we have the Earth and the Moon. And, you know, this is not to scale because the Moon would be much further away. But let's say we have a strange car that can fly into space, and we want to go to the Moon at 100 kilometers per hour. No break. No bathroom break, nothing. How long would it take us to drive to the Moon if we could drive that distance? think about it for a second in your head. Maybe you write it in the chat if you have an idea. We won't take your answers by microphone, but if you want to just write them in the chat if you have an idea, at least take a second to think about it. Driving to the moon at 100 kilometers per hour, you know, that's the speed we go at on highways, so it's not that long. Oh, okay, see, that's when we actually have no idea, right? We get answers from 10 days to 4 years, right? Well, you never know, right? Basically, you have no idea. It's really hard to wrap our head around that. Well, actually, you guys are thinking it's really, really far. It's actually 5 months. So, 10 days, you're not so far in the sense that, 20 years would be very long to go to the moon. So 5 months is still pretty far if you think about it. In a car, nonstop. Yes, 3 days in a rocket, but 5 months at 100 kilometers per hour. That's the moon. That's our closest neighbor. Now imagine we do the same to the sun. And we wouldn't want to drive to the sun, but let's say we could. How long would it take us? Now we're going in years, right? 8, 9 years, 4 years, a long time. Yeah, there we go. That's the best answer. We have no idea. We'll just put a long time. Well, here's the answer. Ta-da! 171 years. So just imagine the moon takes 5 months, the sun takes 171 years. And that's still close to us. That's the nearest star to us. That's in our solar system. So when you see drawings like this is definitely not to scale because there's no way we could represent the solar system on one image. The objects would be way too small, spaced out so much that you wouldn't see them. And it's still mind-blowing. And again, it's still just our solar system. Now, let's have a look at a video. And you might have seen videos like this online because they're very popular. Size of stars and planets, if you can see that online. I don't think there's any sound, but so we start with the Earth, and then we can see compared to other objects. Jupiter already, much bigger than the Earth. Now we're going to see other stars. So this one, I don't even know how to pronounce it, Tidy 1, I'm not sure. That's a star that's sort of a brown dwarf. It's between planets and stars. And same with Proxima Centauri. This is the closest star to the sun, actually our neighbor, but it's a red dwarf star. So it's much smaller than the sun and redder. Remember the Earth? Now this is our sun.
The sun, oh my God.
And wait, the sun is a relatively small star.
Sirius! Oh my God!
Sirius, which is a star you can see in the sky. And now we're getting into the red giants. Pollux, again, I saw it last night. It's a star you can see. Arcturus. Are you starting to feel small? I'm gonna faint. Yeah, you kind of need a, you get an existential crisis when you realize how big the universe is. And wait, we're not done yet. These are blue giant stars. They're very big, very hot, but they're not the largest type of stars. The largest types are red supergiants. And yeah, someone has seen another video, You Ice Cutie. My kids love that one. Betelgeuse is a red supergiant star you can see tonight in the constellation Orion as well. And I'm thinking in this video they put You Ice Cutie, but they put some other big stars. But anyway, if you this is usually my favorite part when I do this in person because everybody's like, like no one is silent anymore. Everybody's mind is just blowing. So yeah, it's pretty impressive, right? We feel very, very tiny when we see this. And what's impressive is that these are just objects in space, right? In the sense that all of these are part of just one galaxy. What we just saw are stars, some planets at the beginning and then stars. And a galaxy contains billions of stars. So in this image, this is a drawing, but it's sort of a representation of our own galaxy if we could go outside and see it. And so everything you just saw, there are billions of them just in that image. Right? We're just like, oh, wait, I can't take this anymore. This is just too big. And look at this picture. Everything in this picture, except for, I won't be able to point it, but the ones that have spikes like that, those are stars in our own galaxy. But I think we see 2 stars in this image. Everything else is an entire galaxy, each of them with hundreds of billions of stars. And it's just, and again, each star has its own planets, most likely. We think there are more planets than stars in our galaxy. So again, you're looking at hundreds of billions of stars and planets, and whoa, right? It gets very big, and it can be destabilizing. You kind of get a sense of vertigo. And I have to tell you that I'm still like that. I still don't fully comprehend how big the universe is. It's just completely beyond our everyday life. But I find it fascinating that we're part of that. And we're just, like, we're part of this whole universe. And this is my last point. Actually, I'm going to finish with that and then take some questions if we have time. We're part of this universe, and the universe is part of us. I'll come back to that in a sec. But basically, when we see pictures like this, it's just like, whoa, this is so far away, right? And you feel completely insignificant. But I like to say that we're pretty amazing with our brains. We have been able to study that, take pictures of things so far away. We're big in intelligence and finding ways to put things together and understand and create telescopes that allow us to study things that are so far away we'll never get to travel there. And in all this universe, there's a little place we call home, and there's our planet. And sometimes we divide things in Earth and space, but in astronomy, it's all part of the universe, right? The Earth is a planet in space. It's part of it. We are part of the universe. And I find it very interesting when you realize, yeah, we're small, we're stuck on this little planet, but we can study and wonder at everything that's out there. And it's just so beautiful. This is a picture from a website where you can see pretty much the Earth every day. It takes pictures. It's a satellite that takes pictures of the Earth, and you can go on it. And usually when you go, like today, if we went to the website, it might have yesterday or 2 days ago, the pictures. But it's pretty interesting to see changes. And sometimes there are big hurricanes. You see them as well. So I love this website. Seeing the Earth from space can really give us a different perspective on our planet. This is where we can live. This is all of us together. We're on that spaceship. This picture is actually taken by the Apollo astronauts just around the moon. So that's the surface of the moon you see in front. But yeah, the Earth is our spaceship, right? That's where we can live. We travel through space with it. And we need to take care of it because that's the only spaceship we have. We can't go somewhere else, right? This is our home. This is what makes life possible in the pretty hostile universe. You need air, you need oxygen, you need water, you need the right temperatures. The Earth is perfect for us. And as we move even further away, this picture might look like nothing, but look at that little dot there. That's us. That's Earth. Think of everyone that you've ever known. Think of all the history of humanity. It all happened on that little blue dot right there. And I think that really puts things in perspectives. And when you think about conflicts in the world, and it's irrelevant to fight for parts of our planet. When you look at, we all live on this tiny dot together. We're all citizens of planet Earth, right? We're all in this together. And I really, truly believe that the world would be a better place if we all understood that. And that's why I'm telling you, because you are the leaders of the futures. And I want you to get a sense of, hey, we're part of this little dot together. This is another picture of Earth right here, taken around Saturn. So that was a space probe around Saturn. So these are Saturn's rings, and it looked at Earth, and Earth is right there. And I find that very beautiful to think, hey, this is where we were. This was taken in 2003, I believe. I'm not sure. But, when you think of that day, everything that was happening on Earth, there it is. It's on that picture, right? It really puts a different perspective on our planet. And one thing that's amazing that someone wrote in the chat earlier is that we are connected with the universe. You are made of stardust. We look at the universe and it looks very far away, and everything looks very far away from us. But all the material that makes your body, the carbon, the oxygen, the nitrogen, everything that's inside your bodies once was created inside a star. You needed stars to create those elements. Those elements were thrown out in space. They were part of a nebula. Eventually, that nebula formed a solar system. Some of it went on the sun, some of it went on Earth. And that material eventually traveled around the Earth, it was in different forms and gas and, rocks and so on. And eventually the carbon, for example, ended up in your bodies. And I love to think that, to look at my hand and say, hey, I'm made of stardust. Isn't that amazing? That's our connection with the cosmos. We're all the same recipe. All living creatures basically are the same recipe. And that recipe includes stardust. And I will stop here. And I think many of you had questions.
Julie, I wanted to firstly thank you for that wonderful tour of your 5 favorite things in the universe, and what a wonderful message to end on. The fact that while we might feel such a small part of the larger universe, that the universe is part of us, and more importantly, the universe is part of everyone and everything that we see. So with that message, I think that's something for everyone to think about. It is a very important message. So maybe we can start by taking a few questions.
Aren't USGOD to Stevenson 218 red hypergiants?
That's a good question. You know, I don't know everything about the universe. So that specific star, I don't know. There are so many stars. So if you read somewhere that that specific star is a red supergiant, it probably is. Again, there's so many stars.
It's not a red supergiant. I'm pretty sure it's called. I'm pretty sure USGOD to Stevenson 218 in between stars 2 are called red hypergiants.
Oh, hypergiants? Maybe. To be honest, I don't see that term used a lot in the scientific world. Maybe it's just because it's such a big supergiant that eventually people created a new term for it. But it's not a term that I hear a lot between scientists. But maybe it's a new term I haven't heard yet. So I can't confirm either way. But I know they're extremely large. So yes, they might be called hypergiants.
Yeah, there's so many objects in the universe, and you know, as the astronomers start naming them, it's hard to keep track of them.
Yeah, exactly.
And also, does Neptune control the Kuiper belt, basically, including the dwarf planets?
It does not control it, but definitely its gravity affects object in the Kuiper belt. The Kuiper belt is sort of the second asteroid belt very far away in the solar system, where there are many objects like Pluto. So smaller objects, but you know, Pluto is still bigger than many asteroids. But anyway, there's a lot of them in the Kuiper belt, and definitely the gravity of Neptune would affect some of the like the way some of the objects in the Kuiper belt. But I wouldn't say it controls it. Let's put it this way.
I think there was a binary star system, and then one of the stars got caught by a black hole, and then like the black hole kept on the star. It kept eating its material, and then once the star got like most of its material outer layer gone, I'm pretty sure it managed to get out the black hole's gravity.
Yeah, so binary systems are where you have, let's say, 2 stars orbiting one another, and when one of them becomes a black hole, then there's definitely matter that goes from the other star into the black hole.
No, like there was a binary star system, and then a black hole came by and then stole one of the stars.
Oh.
So that, and then the black hole kept getting the matter out of it, and then eventually the star got all of its outer layers gone, and then the star left just because it got the gravity out of it.
I haven't heard of that specific example, but yes, definitely there's some weird stuff happening and you do see that. We do see interactions of stars. It might have been something, was that in the news recently? I know there was one story a bit like that I missed.
I think it was like around 2016.
Oh, okay. It's a while back. But yeah, we do see interactions between stars and black holes. And sometimes scientists say like sort of, hey, a black hole swallowed a star, because they don't see it happening live, but they kind of see some of the matter that gets heated a lot as it falls into the black hole. And then you can detect very hot materials and that radiation that comes from it. So yeah, you seem to like it a lot. You have a lot of good information there.
I'm impressed at how much you know. Very well done.
Yeah.
Let's move on.
What is the biggest thing in the universe that isn't a galaxy?
Well, actually, you have clusters of galaxies. So the largest structures in the universe, I guess that we call really structures we give a name to, are super clusters of galaxies. So imagine all those galaxies, many of them put together, that's a cluster. And then you have super clusters of galaxies. And at this point, you kind of just go, you know, it's too big. Like I can't even really figure it out. But I guess, and you know, the universe is just so big, it might be infinite. That's also kind of scary to think about. It kind of gives you vertigo. But yeah, so there are things bigger than galaxies, but the names that we give them are clusters and superclusters of galaxies.
Does that answer your question?
Yeah.
Okay, great.
By the way,
So-
as I was listening to a question, I managed to put a link in the chat. So, like again, if you go to our website, a lot of it is for mostly adults to help teach astronomy. But there's a link specifically when the pandemic hit, we decided a series called Astro at Home directly for age 12 years old. And if you go there, you'll see many subjects. Some of it is, it's from 2 years ago. So some of it might not be like, if you say the sky tonight, then it might not be as relevant. But hopefully you'll find some subjects like gravitational waves and black holes and life in the universe and things like that that might be interesting.
I want to thank you again, Julie, for the wonderful lecture and for sharing your time with us. I wanted to remind everyone to visit the donate page and encourage your friends and families to donate what you can. And I think, Aaron, you wanted to say a quick word about our Join the Journey event as well.
Yes, our newest activity, Stars of the Week, is also presented by Julie. So if you're fascinated by stars and constellations, then you can watch Julie's Stars of the Week video and share what you discovered. And as always, remember to question, discover, and create. And we hope you have lots of fun.
So thank you again, Julie. And we look forward to seeing all of you again in March. Take care. Have a great month.